students, in this chapter algebraic expressions, we have already discussed about the basics of algebra and the three operations, that is addition, subtraction and multiplication on various algebraic expression. And in the last video, we had discussed about the division of monomial by monomial expression. So today's video is going to be about the division of binomial as well as trinomial expressions by monomial expression. So let's get started. But before starting our topic, students, we will quickly recall about the signs and the various rules for signs, right? So here you can see that we have taken the two like signs, that is plus and minus and minus. So whenever the like signs get divided, they give us the answer as plus. Similarly, if we are having the unlike signs and they are getting divided, they will always give us the sign minus as the answer, right? So now here next is the quotient law. What is the quotient law? Whenever the bases are same and their parts are different or maybe the same and they are getting divided, the bases are getting divided, their parts will always be subtracted. Like this, x raised to power a divided by x raised to power b is equals to x raised to power a minus b, right? Next is exponent law. What is exponent law? That is x raised to power 0 is equals to 1. What does it mean? It means that whenever we are having any variable or any number raised to power 0, that will always be equals to 1, right? So now we will start our topic. So students, today we are going to learn about how to divide the binomial and trinomial expression by monomial expression. So let's get started with the first example. Here it is. Just read the statement first. Divide 6x raised to power 5 plus 18x raised to power 4 by 3x square. Now first of all, we will see that which type of expression is given to us. Here you can see that two terms are there, so that means it will be a binomial. And here only one term, that means it is a monomial expression. So now we will start our question. Here you will see that this statement is getting divided by this statement, right? So here you will write first 6x raised to power 5 plus 18x raised to power 4 in the numerator. By means divide, so you will put the sign of divide, that is upon, by 3x square. So you will write here 3x square in the denominator place, right? Now students, what does it mean if I'm putting here upon sign? If I'm writing here 6x raised to power 5 plus 18x raised to power 4 whole upon 3x square, what does it mean? It has a so simple meaning that the 3x square is dividing this whole expression. That means these both terms of this expression. So we can write these both terms of this expression as this, right? So we can divide them or we can separately divide them by 3x square like this. So we can write here 6x raised to power 5 upon 3x square plus 18x raised to power 4 upon 3x square, right? Now what to do, how you can solve it? First of all, we have to see here the numerical coefficient. And we have to see that on which common table both these numericals will be cut. So here you can see 3 1s are 3, 3 2s are 6, right? So here you will write 2 upon 1. Now what is there? Variables are there. So x raised to power 5 upon x raised to power 2. So which part is smaller? So here you can see that 2 is smaller than 5. So you will shift 2, right? So x raised to power 5 minus 2. You will write the base only once. Next is plus 3 1s are 3, 3 6 are 18 and x raised to power 4 upon x raised to power 2. So you will write here 6 upon 1 and x raised to power 4 minus 2. Now whichever law we are following, so whichever law we are using here, you have to write to the right hand side, right? So here you got 2 upon 1 x raised to power 5 minus 2 plus 6 upon 1 x raised to power 4 minus 2. So now how can you solve it? Now here 2x raised to power 3. If I'm not writing here 2 upon 1, doesn't matter, because in denominator if we don't write 1, so it's okay. So here you can write here 2x raised to power 5 minus 2, that is 3 plus 6x raised to power 2. So this is what exactly we were finding for this given statement, right? So now move to the another example, that is example number 2. Now here's the example number 2. Read the statement. Divide 16a square b minus 20ab square by 8ab. So now here you can see again a binomial expression is getting divided by a monomial expression. So with the same pattern, we will solve this question again. So you have to write here binomial first in the numerator, please. Bi means divide, and in the denominator you have to write 8ab. So now what does it mean, this green line that is upon sign? It means that 8ab is dividing 16a square b. At the same time, it is dividing minus 20ab square. So we have to separate them like this. 16a square b upon 8ab minus 20ab square upon 8ab, right? Now we have to cut the numerical coefficients on the same table. So 8 ones are 8, 8 twos are 16. So now you will write here 2 upon 1. Side by side you have to write a raised to power 2 and a raised to power nothing. So whenever a raised to power nothing means what? A raised to power 1. Any variable who has no power, that means it has one power. So here you can see that a raised to power nothing. So you have to write here a raised to power 1. So here you have to write a raised to power 1 as well as here b raised to power 1, b raised to power 1. Now a raised to power 2 and a raised to power 1, which one is the smaller part? That is 1. So you have to shift the smaller part. You have to write here in the numerator a raised to power 2 minus 1 and here b raised to power 1, b raised to power 1. So both the parts are same. So whichever place you want to shift that part, you can shift. So you will write here b raised to power 1 minus 1. Next one is minus. On 8 table 20 doesn't come. So you will cut it on 2 tables. So 2 4s are 8, 2 10s are 20. 2 2s are 4, 2 5s are 10. So further we can't cut it because 5 and 2 does not come on one single table, one common table. So you have to write here as it is 5 upon 2, a raised to power nothing again, a raised to power 1 and again a raised to power 1. So you have to write here a raised to power 1 minus 1, b raised to power 2 minus 1, right? So now I am using here this law, that is x raised to power a divided by x raised to power b is equals to x raised to power a minus b. So we have to write side by side the laws whichever we are using in the given statement, right? So here you got 2 upon 1 a raised to power 2 minus 1. What does it mean? 2 upon 1 means 2. A raised to power 2 minus 1 means what? A raised to power 1. B raised to power 1 minus 1 means B raised to power 0. Minus 5 upon 2 a raised to power 1 minus 1, that is 0. B raised to power 2 minus 1, that is 1. Now, here you can see that 2 is 2, a raised to power 1. If I'm not writing here in the power 1, so it is okay. Now, next is B raised to power 0. What does it mean? We just have discussed the law. That is exponent law. What is the law? That is any variable whose power is 0, the result will be 1. So here b raised to power 0 means 1. So if I'm not writing here 1, that is okay. Next is minus 5 upon 2, a raised to power 0. Again, it will be 1. So we don't have any need to write it here. And b raised to power 1. So simply you can write here b. So the answer is 2a minus 5 upon 2b. Right? So now move to another example, that is example number 3. Now student, first of all we will read the statement. Divide minus a plus 4a raised to power 3 minus 3a raised to power 4 by 4a. So now first of all we will see that which type of expression is this. So you will count the terms. So 1, 2, 3. So here 3 terms are there. So which type of expression is this? Yes, this is trinomial expression, right? Now here again 4a is a single term, so it will be monomial expression. So here we are dividing here trinomial expression by monomial expression. So with the same pattern, with the same step that we have followed in the previous example, we will solve that sum. So here you will write the first expression, that is this trinomial expression here, and by means divide, and 4a you will write here. Again, what does it mean? This green line, this upon sign, we will understand about it like 4a is dividing all these 3 terms of this expression separately, right? So minus a is dividing by 4a. Similarly, plus 4a raised to power 3 is dividing by 4a. At the same time, minus 3a raised to power 4 is getting divided by 4a, right? Now here you have to write the statement like this, minus a raised to power 1 upon plus 4a raised to power 1. plus 4a raised to power 3 upon plus 4a raised to power 1. Next is minus 3a raised to power 4 upon plus 4a raised to power 1. Now here you can see that here with the numerator minus sign is there and denominator plus sign is there. So first of all, we will start solving these signs. So we have already discussed about how to apply the laws for signs. So whenever the unlike signs are getting divided, the answer will always be minus. So we have written here minus. Now what is there? If here no numerical coefficient is there, that means 1 is there and upon 4. So we can't cut 1 and 4 on any table. So we will write as it is as 1 upon 4. That is minus 1 upon 4. Now here a raised to power 1, a raised to power 1 both are same parts. Both are same variables. So you have to write it here as a raised to power 1 minus 1. Next is this circle you can see plus plus. Both are like signs. So whenever we are dividing like sign, the answer will always be plus. So we have written here plus, right? Next we are having 4 upon 4. That means 4 will cut on their own table. 4 ones are 4, 4 ones are 4. So here you will write 1 upon 1. A raised to power 3 divided by a raised to power 1. So here smaller power is 1. So you will shift that part to the upper side, that is a raised to power 3 minus 1. And here you can see again the unlike signs are there, minus and plus. So unlike sign, sign of minus. So you will write here minus 3 upon 4. We can't cut them on the single table or on a common table. So you will write here 3 upon 4 a raised to power 4 minus 1. So we have followed that rule, that is x raised to power a divided by x raised to power b is equals to x raised to power a minus b. So you have to write that law here, right? So next one is there minus 1 upon 4 a raised to power 1 minus 1. So you will write here minus 1 upon 4 a raised to power 1 minus 1 is what? 0. So any variable raised to power 0 is what? 1, right? So you don't have any need to write here a raised to power 1. So that will be a raised to power 0. So here you will write a raised to power 0, right? So here we have written minus 1 upon 4 a raised to power 0 plus 1 upon 1. If I'm not writing here 1 doesn't matter. So you will write here a raised to power 3 minus 1, that is 2, minus 3 upon 4 a raised to power 3, right? Now here you can see that students x raised to power 0 means 1. So that means what? X a raised to power 0 means what? 1. So the answer will be only as minus 1 upon 4, right? So here you will write minus 1 upon 4 plus a raised to power 2 minus 3 upon 4 a raised to power 3. So this is the answer for the given statement. Now move to the another example. Now here we are having the given statement as divide 18 x raised to power 2 y z minus 28 x square y square z cube. And next one we are having 32y square z square by minus 4xy. Such a big statement? Not really. We are having the given expression as in the trinomial form. Why trinomial? Because it contains 3 terms. So we will count them, that is 1, 2 and 3. And here one term, that means monomial. So we are dividing this trinomial by monomial, right? So we have just changed the variables here. Earlier we were taking the single variable like a or x or b. Here I have taken the 3 variables altogether, right? So you will understand how to divide the given variables or the given numerical coefficients by the monomial expressions. So here you can see you will write the given statement, that is the first expression here in the numerator, and by means divide, and minus 4xy in the denominator. Now we have to write this expression separately. Why separately? Because this upon sign means that minus 4xy is dividing all these 3 terms of this expression separately at the same time, right? So you have to write them separately or individually like this. Plus 18x square yz upon minus 4x raised to power 1 y raised to power 1. So see, you can see here, if any variable who has no part, that means one part, so you have to write there. Next is minus 28 x square y square z cube upon minus 4xy, right? Next is plus 32y square z square upon minus 4xy, right? So first of all, you can see the circles here. So you have to solve these signs. So there are unlike signs. So whenever the unlike signs are getting divided, the answer will always be as minus. So here you will cut these numerical coefficients. On 4 table, 18 doesn't come. On 2 table, we will cut them. On 2 2s are 4 and 2 9s are. 9 and 2 can't cut further because both these tables doesn't come on one single or common table, right? So you will write a minus sign upon 2. Next is what? X raised to power 2 and x raised to power 1. Smaller power is what? 1. So you will shift 1 to the upper side. You will write here x raised to power 2 minus 1. Y raised to power nothing means 1. Y raised to power 1. So you can write here y raised to power 1 minus 1. Next is z raised to power nothing. That means z raised to power 1. If you are not writing here, doesn't matter. Next is minus minus. Which sign are these? These are like sign. So like sign, sign of plus. So 28 divided by 4. So you can cut them as 2 2s are 4, 2 14s are, then 2 1s are 2, 2 7s are. So that is 7. X square and x raised to power 1. So you will shift 1. So you will write here x raised to power 2 minus 1. And here you can see y square and y raised to power 1. So you will write here y raised to power 2 minus 1 and z raised to power 3. Right? Now here again unlike sign. Unlike sign means sign of minus. 4 1s are 4, 4 8s are 32. So you will write here 8 upon 1 y raised to power 2, y raised to power 1. So you will write here y raised to power 2 minus 1. Next is z raised to power 2. So you will write here z raised to power 2 and x as it is because we don't have x variable in the numerator. So you will write x as it is. Right? Next one is that how to solve these. Minus 9 upon 2, x raised to power 2 minus 1, that is x raised to power 1, y raised to power 1 minus 1, that is 0. You have to write here y raised to power 0 and z as it is. Next is plus 7, x raised to power 2 minus 1, that is 1, y raised to power 2 minus 1, that is 1, z raised to power 3. Minus 8 upon x. If I'm not writing here 1, hardly matters. So you have to write here 8 upon x, y raised to power 2 minus 1, that is 1, z raised to power 2. Clear? So, students, you can see here minus 9 upon 2 and x raised to power 1. If I'm not writing here 1, you know that it's okay. If you're writing here, that's also okay. So, y raised to power 0 means what? Y raised to power 0. So, you move to directly here. Any variable raised to power 0 is what? 1. So, y raised to power 0 is 1 as well. So, you don't have any need to write here 1. So, z will be z plus 7 x y z raised to power 3 and 8 y z square upon x. So, this is what we were actually finding for the given statement, right? So, students, these were very easy examples and now I hope all of you have understood this concept completely, and for the better understanding, please student go through the YouTube links because all these links will definitely help you, and now all of you are able to do the related homework that we have already sent you in your SNAP homework. Thank you.